Hello viewers, welcome to CEC lectures. Myself Dr. Priti Jagwani. I am from Department of Computer Science, Albert College, University of Delhi. In my previous lecture, which was related to knowledge representation in AI, we looked into how are we going to define the knowledge formally, and then we also tried to see what actually knowledge representation is and what are the core methods of knowledge representation. So, three core methods of knowledge representation we have seen in the previous lecture, which were kind of logic based system. Then comes the propositional logic, and the third one, which is the FOL, which is first order logic, which is kind of an extension of the propositional logic, and within the propositional logic it is introducing variables, quantifiers and predicates. From that representation of core methods of knowledge representation, I am moving to kind of the structured representation of knowledge. So, the structured representation, when we talk about it, actually tries to mimic how humans categorize the information, and within these structured representation, these are the methods actually to organize the knowledge hierarchically or through networks. So, the first structured representation way of first structured way of knowledge representation we can say is semantic networks, which is often commonly known as semantic nets. So, that represent knowledge as nodes. So, concepts are being kind of represented as nodes, and the relationships between these concepts are depicted in the form of edges. For example, dog is kind of linked to an animal, and the connection is going to be is a. So, dog is a animal. So, is the connection and the concept, or we can say node. So, one side we have the node dog, another side we have animal, and there is a connection is a between them. And they simplify actually kind of we can say inheritance reasoning, but there is a lack of formal semantics. This representation of dog is an animal like this is actually not in terms of formal semantics. Then comes frames. So, frames is actually something or a structure which is going to group related attributes. For example, a vehicle frame may include some slots like wheels, engine types and fuels, and these frames actually kind of are very important or kind of very promising when we need default reasoning. These frames excel in default reasoning, but they struggle with kind of exceptions. So, we have frames, we have semantic networks, then we have ontologies, which is generally used by kind of e-commerce platforms in order to classify products and enhance the search accuracy. Now, these ontologies actually define the concepts, hierarchies and relationships within a domain using standard ontology languages like OWL, which is a web ontology language. Ontologies power semantic search engines, and healthcare diagnostic is also one of the applications by standardizing the terminology. So, if you want to have an terminology which is in the form of which is kind of a standard terminology, ontologies are the best to use. So, e-commerce platform use these ontologies in order to classify products, so that the accuracy of search can be enhanced. Apart from that core methods and structured representation, we also have probabilistic models for knowledge representation, and these probabilistic models are actually the systems which handle the uncertainty by assigning some probabilities to the outcomes, because the outcomes are not certain, they are uncertain. So, they can be uncertain by a particular degree. So, that degree is captured in the form of a probability of the outcome. And in this probabilistic models, we have Bayesian networks, which are going to use directed graphs to model causal relationships. Each node in the Bayesian network represent a variable, and the edge denotes the conditional dependency. So, for example, for instance, a Bayesian network can predict the likelihood, which is again kind of a probability of equipment failure based on the maintenance history and usage. in this category of probabilistic model, apart from the Bayesian networks, we also have MDP. MDP is Markov decision process, which is used to model the decision making in dynamic environment, and these MDPs help robotic systems navigate obstacles by evaluating potential actions and rewards. So, for example, weather prediction systems combine historical data and the sensor inputs using probabilistic models to forecast storms. So, these two kinds of probabilistic models we have seen, Bayesian network and Markov distribution process, which is MDP. Apart from this, we have some distributed representation, which are basically used by modern AI. So, for example, we have neural networks which are there to encode knowledge as in the form of numerical vectors, which is with the help of these numerical vectors, the latent patterns in the data is being kind of captured. Moving further, we also have knowledge graphs. So, knowledge graphs is combining the graph structure with embeddings to represent entities. These entities could be any people or a place, and then this graph structure is also used to model the relationship or to represent the relationship between these entities. So, Google's knowledge graph enhances the search results by linking related concepts. So, knowledge graph is basically used for your kind of searches inside the search engines. Then we have some embeddings within this. So, embeddings is where we convert the words, images or entities into some dense vectors, as we kind of do generally in the domain of knowledge NLP, which is natural language processing, and with the help of word embedding like word to vector map, synonyms to nearby vector, we are going to enable, or we generally enable, the semantic analysis of any particular text or any particular we can say word. Then apart from embeddings, we have seen the knowledge graphs in the distributed representation, we have seen the core models, and we have seen the probabilistic models and the structured representation also. Now, when we talk about the knowledge representation, it is very important to talk about the AI knowledge cycle. Now, what is this AI knowledge cycle? The AI knowledge cycle represents a continuous process through which any AI system acquire, process, utilize and refine the knowledge. So, there is an AI system who is going to acquire the knowledge, process the knowledge, utilize and refine the knowledge. Now, in an AI knowledge representation cycle, we have knowledge acquisition is going to be kind of acquiring the knowledge, then we have knowledge representation of that knowledge, followed by knowledge processing and reasoning, whatever representation you have in a particular format, depending on your kind of problem domain, we need to process and reason out. Then we have knowledge utilization, you need to utilize that processed knowledge, and finally you need to refine the knowledge which is already stored, and there involves a process of learning also. So, this is actually AI knowledge kind of representation cycle, with the main steps as knowledge acquisition, knowledge representation, knowledge processing and reasoning, knowledge utilization and knowledge refinement and learning. Now, when we talk about this AI knowledge representation cycle, this cycle ensures that your AI remains adaptive and improves over time, and hence we say the machines are learning. So, first step, as we have seen, was the knowledge acquisition, which is kind of gathering the data from various sources, including any structured database, any unstructured text, images, real world interactions. So, everything which you are kind of posting or giving it on social media, it's actually a kind of data. So, techniques such as machine learning, NLP, which is natural language processing, and computer vision, which is to kind of looking into or capturing the images and then process those images. So, computer vision, machine learning and natural language processing are the techniques which are going to kind of enable this acquisition. After acquisition of the knowledge, we need to represent this. Once acquired, knowledge must be structured for efficient storage and retrieval, and then in this step it is also represented through the methods which we have already explained, the core methods, then we have the structured representation, then we have distributed representation, that we have probabilistic representation and so on and so forth. After this knowledge representation, there comes knowledge processing and reasoning. So, AI applies some logical inferences, some probabilistic models and deep learning to process whatever knowledge is being kind of acquired and represented. This step of knowledge processing and reasoning allows artificial intelligence to draw conclusion on the basis of deductive or inductive reasoning, allows artificial intelligence to solve the problems using heuristic search. Please recall, heuristics is something which we have already stored, heuristic search and optimization, and also it allows an AI system to adopt through reinforcement learning and experience also. So, after this knowledge processing and reasoning, when we talk about we come to the next step is utilization of this knowledge, which is knowledge utilization. So, AI applies the knowledge to the real world task, including kind of some predictions, some automations, some decision makings could be there. For example, virtual assistants understanding user queries is actually utilization of knowledge. Then we have AI powered recommendation systems which are suggesting content. We have self driving cars making real time navigation decisions. This is also these all kind of are being done on the basis of whatever knowledge is being represented and processed, reasoned out, and this is what we call is utilization of knowledge. Then it is not only the utilization of the knowledge which is being done by the AI. AI also continuously updates its knowledge base through some feedback loops. So, techniques like reinforcement learning, supervised fine tuning and active learning, which are these are the terms which are generally covered in the course of machine learning. Active learning, these supervised fine tuning or reinforcement learning, they help improve accuracy and adaptability, and then this ensures that AI evolves based on new data and experiences, and that new data and experiences are again going to be stored using some structured representation inside the knowledge base. So, this AI knowledge cycle with the help of this feedback loop actually becomes iterative. So, these AI systems refines the knowledge continuously, ensures the adaptability and long term learning, and also please remember that this cycle forms the backbone of the intelligent systems, enable them to grow smarter over time. Now, when we say we have seen how are we going to represent the knowledge inside a knowledge base, or what are the formats of knowledge representation for any AI system. Fine, but what type of knowledge is there in AI systems, we also need to see that. So, AI systems rely on different types of knowledge in order to function efficiently. Each type serves a specific role in reasoning, decision making and problem solving. Now, what all are the primary types of knowledge which are being used in AI? So, one is, or the first one is the declarative knowledge, or we can say descriptive knowledge, which consists of the facts, information about the world that AI system is going to store and retrieve when it is kind of needed. With the help of this declarative knowledge, with the help of these facts and kind of rules, we can say it represents what is known rather than how to do something. So, whatever is the current state of the environment, I can say that can be kind of easily depicted with the help of these declarative or descriptive knowledge. This type of knowledge is often stored in the structure format like databases, ontologies, or even knowledge graphs. So, for example, we have a fact that Paris is the capital of France. It is a declarative knowledge, it is a fact, and AI applications like search engines and virtual assistants use this type of knowledge to answer some factual queries and provide relevant information. So, in this declarative knowledge, it is the component what is being represented, how is kind of how a dimension is missing. So, now how dimension comes in the procedural knowledge, which is actually we can also say that it is a how to knowledge. So, procedural knowledge defines the steps or methods required to perform the specific task. It represents how to accomplish something rather than what actually this is, or rather than just stating the fact as we have done in the kind of descriptive knowledge. Let us take an example. We need to solve a quadratic equation, or we need to see how to drive a car, which this falls under this procedural knowledge. So, AI systems such as expert system robotics utilize procedural knowledge to execute tasks that requires some sequence of actions. This type of knowledge is often encoded in rule based system, decision trees and machine learning model. So, these are actually the procedural knowledge, while your declarative knowledge was actually kind of we can say depicted or stored in the form of databases, ontologies and knowledge graphs. Apart from procedural and declarative, we also have meta knowledge. So, meta, when we say, or meta knowledge, we say it is knowledge about knowledge. So, meta knowledge actually refers to the knowledge about how information is stored, how this information is going to be used and validated, and this meta knowledge, which is knowledge about knowledge, it also helps AI to determine the reliability, relevance and applicability of knowledge in different scenarios. Let us take an example. So, for example, an AI system deciding whether a piece of medical advice comes from a trusted scientific source or it is from a random blog post is actually kind of using meta knowledge. That is, you are actually kind of checking, or you are verifying the source of the knowledge. So, it is the knowledge about that piece of medical advice, which is knowledge about knowledge. So, this type of knowledge are actually crucial in AI models for filtering misinformation, optimizing learning strategies and improving the decision making. So, procedural, we have declarative, we have meta knowledge, followed by the next one, which is the heuristic knowledge. Heuristic knowledge, we can say it is also it can also be called as experience based knowledge. So, heuristic knowledge is derived from the experience, intuition and also kind of trial and error method. It allows AI system to make guesses which are smart or educated guesses, we can say, or approximate solution when the exact answers are kind of difficult to compute. So, if we do not have any kind of specific rule, we can go with the kind of heuristics, we can say. So, again example could be a navigation system which is suggesting an alternate route based on the past traffic patterns is applying some of the heuristic knowledge. So, AI search algorithm like A star search and genetic algorithms leverage these heuristics to optimize problem solving process, decision making and making decisions more efficient in the real world scenarios. So, apart from this heuristic, procedural, declarative and meta knowledge, we also have something which is very important, and this is known as common sense knowledge. So, common sense knowledge that represents the basic understanding about the world that humans acquires naturally, but it is very challenging for any AI system to kind of acquire that knowledge which is being kind of obviously or naturally is built inside the humans. So, it includes facts like water is wet. So, that is a fact, we as human beings we all take it kind of very obvious, but for an AI machine we need to make the machine understand that water is wet. Or the second fact could be, or the natural situation could be, if you drop something it is going to fall. So these kinds of knowledge is we need to kind of represent inside the uh, AI systems. AI systems, if we talk about, they often struggle with this type of knowledge, but because it requires some kind of contextual understanding beyond explicit program. So it is not only the explicit programming which is going to built in kind of this common sense knowledge inside the AI systems, but some contextual understanding is also required. So researchers are integrating common sense reasoning into AI using large scale knowledge bases such as concept net, which help machines understand everyday logic and improve their interaction with humans. When you kind of design an AI system and it is employed for a particular domain, for example, let us say healthcare, or kind of weather prediction, or financial some predictions. So there are different domains in which you are going to use your AI system. So here we also need some domain specific knowledge which focuses on specialized fields such as you have medicines, law, engineering, finance. It includes highly detailed and structured information relevant to a particular industry or related to a particular domain. So for example, in the medical field, AI driven diagnostic systems rely on the knowledge about symptoms, diseases and treatments. Similarly, if we talk about financial AI models, these financial AI models use economic indicators like economic indicators, risk assessment and market trends in order to kind of give any prediction or something of that sort. Also, expert system and AI models tailored for a specific industry, they require domain specific knowledge to provide accurate insights and predictions. So, till this point we have seen what actually what are the forms in which we can represent the knowledge, and previous lectures we talked about knowledge based systems and so on and so forth. But this representation of knowledge inside an AI system or inside a machine is actually a challenging task. The things which are very very obvious for a human being to perceive, to understand or to kind of comprehend, those are actually we need to kind of explicitly incorporate that kind of knowledge or every knowledge inside a machine, because machine does not think of its own. So there are so many challenges in this we can say knowledge representation thing. So while your knowledge representation is fundamental to AI, it comes with so many challenges. So the first challenge is complexity. Representing all possible knowledge about even a particular domain can be highly complex. It requires sophisticated methods to manage and process this information efficiently. Apart from this complexity, there is ambiguity and vagueness. Human languages concepts are often ambiguous or vague, and the receiving person can make a sense depending on the context. But here in case of a machine, it is difficult to create precise representation for every kind of context, we can say. Then there is an issue of, we can say, scalability. So as the amount of knowledge grows, AI systems must scale accordingly, which can be challenging both in terms of storage and processing power. Knowledge acquisition, if we say, which was the first step in the AI knowledge representation cycle, the gathering and encoding knowledge into a machine readable format is a significant hurdle, particularly in dynamic or specialized domains if we talk about. Then we say reasoning and inferences, again the third step in the cycle. AI systems must only not store knowledge, but also use it to infer the new information, to make intelligent decisions and to solve the problems. This requires sophisticated reasoning algorithms that can operate efficiently over large knowledge bases. With this whole kind of we can say knowledge about the knowledge representation in AI, We also need to look into some of the applications of knowledge representation. It is applied in various domains in AI, enabling the systems to perform tasks which require human like understanding and reasoning. So, some applications of these knowledge representation could be expert system, which uses this knowledge representation to provide advice or make decisions in specific domains, as we have seen medical diagnosis or financial planning. Then we have the domain of natural language processing. So, knowledge representation here in case of natural language processing is used to understand and generate human language, enabling applications like different chatbots, your Siri, Alexa, translation system and others to do some kind of processing. Then we have robotics, which uses robots uses the knowledge represent to navigate, interact with the environment and performs the task autonomously. We also have one kind of application as semantic web, which relies on ontologies and other knowledge representation techniques to enable machines to understand and process the web content meaningfully. So, apart from that, we can also have cognitive computing, which is system like IBM's Watson uses knowledge representation to process vast amount of information, reason about it and provide insights in the field like healthcare and research. So, in this lecture we looked into the different dimensions of knowledge representation, one of which was the applications. We also looked into the challenges, then what all kinds of knowledges are there, that procedural, declarative, meta knowledge, common sense knowledge and heuristic knowledge too. And we have also seen the whole kind of knowledge representation cycle. This is all from my side in this lecture related to knowledge representation. I will see you in the next. Till then, take care. Goodbye.